All right, so section 4, or unit 4, is what we are starting today. It is all about functions and how to evaluate functions. So this is quite a bit of repeat of Algebra 1, and we're also kind of going to cross that border into Algebra 2 this unit. So we'll start off what a function is. A function is a relation in which each element of the domain is paired with exactly one element of the range. Okay, that sounds really fancy. All that means is each x value, because that's what a domain is paired with exactly one y value. That's what the range is. So anytime you hear domain, input, anything like that, that just means your x's, okay? And then your range, those are your outputs, okay? Those are your y's. So if I'm looking at a coordinate point, which numbers are my x's, the first or the second? The first. The first are my x's and the second are my y's. Good. So looking at these first examples, would you agree that 9, 3, 1, and 10 are my x's or my domain?
Yes, ma'am.
Okay. And then 3, 2, 4, and 18 are my range or my y's.
Yes.
Okay. So what we need here is we just need every x to only have one y. Okay, and how we're going to think about this, because it can get a little bit confusing. And I want you to write this up at the top. Think about x's as being people, okay? Your ex-girlfriends, your ex-boyfriends, they are people, okay? And then think about y's being birthdays. Y's are birthdays, okay? So is it possible for two people to have the same birthday?
Yes. No. Me and Mason, yes, sir.
Okay. So two people can have the exact same birthday. That's totally fine. Okay, so my y values, they can repeat all day long, okay? Because different people can have the same birthday. However, can one person have two birthdays?
No, ma'am.
No, they cannot, okay? I celebrate my birthday for an entire month, but technically just one of those days is my birthday.
What?
You don't do that?
You do that?
You don't celebrate your birthday for a month?
No.
The whole month of January, you guys are going to sing happy birthday to me every day.
You sing happy birthday to me.
Oh, it's your birthday month too? Go ahead.
I'm born on the first day of January.
Okay, good. That's a good day.
Oh, so you're
All right, so
2005.
back to what we're talking about though. I can't have two birthdays, okay?
No.
So, when we go to these examples, do any of those x's repeat?
No.
No. So therefore this is a function, okay? Because there's not one person that's got two birthdays. Let's go over to example 2 though.
Whoa. No. Whoa.
Oh, don't say it out loud.
Is that like wait, well, are you saying, wait, what's the yes for?
Hold on.
Yes, it's a function.
Yes, it's a function.
Because the x is
Okay, so I underline my x's in red, my y's in blue. Do any of those x's repeat? Yes. Which one?
the 3.
3, okay? Do we see how 3 has a birthday of 4 and 3 has a birthday of 10? Can that work? No. So therefore this is no, not a function. So I could put no, or I can write it out as a sentence if we're like Chase and we get confused. So yes, a function. Okay? Questions on that?
Yes.
Did you have a question?
What? No, but.
Okay.
Wait, so what if there's multiple Y's? Is that a no?
Well, can you and I both have the same birthday?
Yeah.
Yeah. So the Y's can repeat.
X is people, Y is birthday.
X's are people, Y's are birthdays. X's can't repeat, but the Y's can. Okay? So, the first way, guys, the first way was through coordinate points. We can also display this information as a mapping diagram. Anybody ever seen a mapping diagram?
Yeah.
Okay, here's how you make these. Your x's are going to go in the domain, okay? Because we know that. X's are the domain side. They're going to go in order from least to greatest. And if any of them repeat, you only have to write it once. So 1, 3, 9, and 10 would be the order that domain goes in. We're just using the ones from example 1. How would I put the range in order?
Least to greatest.
Least to greatest. So those numbers, 3, 2, 4, and 18.
2, 3, 4, 18.
2, 3, 4, 18.
Thank you.
Okay? We're not quite done yet, though. The reason we call it a mapping diagram is because the number maps onto its partner. So for instance, 9, 3, 9 maps onto 3. You just draw a line from 9 to 3. 3 then goes to 2. 1 goes to 4. And 10 goes to 18. It doesn't matter which one it goes to, no. But it does matter that only one, or each x only has one y. Okay, so this is still a function. There's not 2 lines coming out of any of those x's. Okay, I want you to go ahead and put example 2 into a mapping diagram. And again, remember that if you have a number twice, you don't have to write it twice. You only have to write it once. Okay, so looking at my x's on number 2, put them in order. So I got 3, 4, 3, and 1. 1, 3, 4. Even though I have 2 3s, I don't need to write it twice. I just got to write it one time. And then for my ranges, I've got 4, 2, 10, and 4. 2, 4, 10. And now we just draw our lines in the right spots. So 3 maps onto 4. 4 maps onto 2. 3 maps onto 10. And 1 maps on to 4. If we look, so just starting from the top down, the first thing I notice is that 1 and 3 both map onto 4. Is that okay? Can 1 and 3 have the same birthday?
No.
Yes, they can. It's okay for 2 people to have the same birthday. But then, let's go down to 3. Can 3 have a birthday of 4 and 10? No. Okay? So that is how I see that this one is still not a function. Okay? So this one is still a no. But if you saw a mapping diagram, you could tell if it was a function just by looking at where those lines go. Okay? The last way that we can do these are as a graph. Okay? So if we look on my x-axis, I just need to have the numbers 1 through 10. So I'm going to go ahead and do that. I'm actually just going to go up by 2s just to make it easier. You can go up by 1s though if you would like. Bless you. Okay. Now on the y's, I just need to go from 2 to 18. I'm also going to go up by 2s. 2, 4, 6, 8, 10, 12, 14, 16, and 18. And now I just plot those coordinate points from above. So we've got 9, 3, which will be about right here. 3, 2, 1, 4, and 10, 18, which is up here. I actually need to write that a little better. 10, 18. Okay, so now if I just connected all of these points, look like that. Not super pretty, but it works. And how to tell by looking at a graph if something is a function or not, okay, is through what we call the vertical line test. Okay, what kind of line is a vertical line? Up and down, right? So what I want to do is draw a vertical line. okay? If it only hits one time, so it hits once, it is a yes, it's a function. If it hits more than once, it's a no, not a function. Okay? This is not the greatest example because I don't like how that line sort of looks vertical, but this actually goes from 9 to 10, so it's not straight up and down, okay? But if I draw a vertical line through anywhere in this graph, how many times does it hit? Just once, no matter where I draw it, okay? So therefore, this is a yes. If there was any point on that graph where it hit more than once, it would be a no. Okay, I want you to go ahead and graph example 2. So look at how far your graph needs to go as far as your x's and y's are, and then plot those points that are there. Okay, so my x-axis, how far do I need to go? X-axis? 1 to 4, right? So I can just do 1, 2, 3, 4. That works. What about my range or my y-axis? 2 to 10. So I can go up by 1s. I could also just go up by 2s. 2, 4, 6, 8, 10. Doesn't matter which way you did. Then we just plot those points. So the first one is 3, 4, 4, 2, 3, 10, and 1, 4. So if I were connecting this, I would kind of have 2 different ways I could do it, but this is probably the way I would do it. Okay, and now I'm going to try that vertical line test. So if I drew it right here, it only hit once. If I drew it right here, it would also only hit once. But what about if I drew it right there through the middle? It would hit more than once. Yep, it's hitting a vertical line. So is this a function? No, it's still not going to be one. Okay. Questions on that? Questions on vertical line test? Does that make sense? You feeling good about it? Okay, so there are 3 ways to display a function. There's actually more, but these are just the ones that we are talking about today. Okay, and they're just the methods that we just used. So the first one was ordered pairs. Second one was mapping diagrams. And what was the third one? Vertical line test, or just through graphing, right? That was the actual method of showing it, but vertical line test was a way of telling if it was a function. Okay. We can write functions in math, and that's what we're going to be doing this unit. And we call this function notation. Function notation. And here's what it is, or here's an example of it. F of x equals 2x plus 4. Raise your hand if you've seen f of x before. You might have even seen it in this class before once or twice. Anybody know what it stands for? No. It actually just means y. So this would be the same thing as y equals 2x plus 4. F of x and y are interchangeable. Okay? So don't get confused by that. When you see f of x, just know that it means y. Okay? And I've seen stuff in the form of y equals mx plus b, right? So could I graph something that was f of x equals mx plus b?
Yeah.
Yeah, because it's the exact same thing. It's basically just y in a Halloween costume. Okay? That's what f of x is. They're the exact same thing. So if you hear f of x or if you hear me say y, I'm talking about the exact same thing. Okay? So now we are going to look at how we use these. Okay? So what we're going to do is we're going to think of domain and range as input and output, which we know are synonyms for that, okay? The input goes in to the function, and the output comes out. So the x's go in, and what do you think comes out? The y's. The x's go in, and the y's come out. Nope. Input's always going to be x, output's always going to be y. And then we got a little note down here. So it says input can also be called independent and output can be called dependent. Do you remember learning in like science class? I think it probably started around like 7th grade. Independent and dependent variables. You with me? So these are the same thing, okay? And if you ever kind of interchange science and math in school, your independent variables are always going to be your x's, and your dependent variables are always going to be your y's. So if you're really good at that in science and you're doing a word problem in math, you can kind of interchange those, okay? So we're going to try our first function machine. So our function rule is f of x equals 3x plus 4, and then it gives me my domain. So it gives me these 4 values for the domain, 1, 2, 3, 4. So what I'm doing is I'm taking each of those numbers one at a time, putting them in to this function, seeing what I get out. And I'm going to record my answers in this table over here. So 1, 2, 3, and 4 are the 4 different domains I got. And now I just got to figure out what their ranges are.
So you just plug them into
Yep, plug them in. So we'll start with 1. Plug it in. So 3 times 1 is plus 4. 7. Okay, and you can actually write that out as well. 3 times 1 plus 4 is 7. Now we're going to do that with the rest of the values. And I don't care if you use a calculator. In fact, it's really good to get in that habit because some of these are going to get a little more hard. Okay? So then the next one is going to be 3 times 2 plus 4. What's that going to be? 10. So that's your next one. What about 3 times 3 plus 4? 13. And 3 times 4 plus 4? 16. 3 times 4 is 12, plus 4 is 16. Good. So, my range then, they just want me to write that just like I wrote the domain. So just using those little parenthesis bracket kind of things. 7, 10, 13, and 16 separated by commas. Okay, questions on that? Cool. It wants you to try the following example on your own, and if you need to draw a machine kind of thing, you can. Or you could just fill in that table. Okay, so it gives you the function f of a is negative 3a plus 5, and it wants you to use this domain to find your ranges. Negative 3, 1, and 4. What? So you plug it in. So like negative 3 times negative 3 plus 5. And then see what you get. So go ahead and work that out. All right, so what did you get for negative 3? 14. Negative 3 times negative 3 is a positive 9, plus 5 is 14. And then we can plug in 1. And what did you get for that?
2.
Anybody get anything different? We all on the same page there? Okay, and then the last one is plugging in 4. Chase, what'd you get? Negative 7. Raise your hand if you agree. Good. Anybody get anything different? Didn't see all the hands up. Okay. Nope. Don't have to. It's good to get in the habit of doing that though, just so you don't mess it up. Okay. We will keep moving along. So when we are writing our own function rules now, okay, this is a big part of your test. It kind of goes back to when you had to find a pattern, okay? You did this in Algebra 1, but you also started this like back in elementary school, but they were really basic patterns, okay? Mm-hmm. Yeah, different shapes, finding the different patterns, and then whenever you got into like basic addition, subtraction, it was finding patterns through that. Which actually, if you look at number 1, and you start looking at that,
Adding 3.
try to figure out what that pattern might be.
Yeah, add 3.
The second one is multiplying.
Okay, so the first one we saw that if we add 3 the first time, 1 plus 3 is 4, 4 plus 3 is 7, 7 plus 3 is 10. Okay, so we're just going to write that the pattern is add 3.
Can you put the symbol up?
Yep, you can do a plus sign. Then we got 1, 3, 9, 27. Think about that one.
Multiply 3.
Don't shout it out. Even though you both already said it, it is times 3 or multiply by 3. Okay. Questions on that? This is something that we're going to have to know how to do. Except for our functions that we're finding the patterns of are going to look more like this. Okay, they're going to be in one of those different displays, probably in a table, okay? And you've got to write a function rule for the table. So, some of these can get a little tricky. This one's really basic, and please don't shout it out right now. But when you get going with these, ask yourself, what can I do to get from the first x to the first y? And if I start by just doing that, don't look at the rest of the table yet, okay? To get from 1 to 5, what are my options? Add 4, multiply by 5, okay? Those are 2. There's probably a billion more, okay? But we'll go ahead and we'll just try those first 2. If I go down here, if I add 4, does that get me from 2 to 6?
Yeah.
What if I multiply by 5?
No.
No, that one doesn't work. So we got one rule that works for both. Let's keep going. Does 3 plus 4 equal 7?
Yeah.
Does 4 plus 4 equal 8?
Yeah.
Okay, that's my rule then. So the pattern is just to add 4 to x. Add 4 to x to get y. Okay? Relate that pattern to your function. So if I had to put this as a coordinate point, something that's going to work for everything. Okay, the x's are themselves, right? And the y is just x plus 4. You with me?
Yeah.
So now if I had to put that to get one step further, we know this is x and this is y. How would I write that in function notation? What does f of x equal?
Y.
Y, which is what?
X plus 4.
X plus 4.
Do we have to put f of x and put y?
I'm not going to count it wrong, but I'd rather you put f of x. I haven't talked to the other teacher if we take off like half a point for that. I'm not sure. But it is function notation, so it should be f of x. Okay?
It's the same thing. Why should it matter?
You're right. You're right. That's fair. It is the same thing.
I'm not arguing. I'm just asking.
Okay. But function notation technically is f of x, even though it does equal y. Okay. Next one. I want you to go ahead and try this one. Please don't shout it out. Okay? Try this one and then compare with your partner. All right, so this one was a little bit trickier, but I saw that a lot of us got it, so I'm happy. How would I get from x to y? What is the pattern that we're seeing here? Multiply by x, right? Multiply x by itself would be the actual pattern. Okay, so multiply by x you could write, or multiply x by itself. Does everyone see that? What is another way that I could word that?
X, times x.
Okay, so you did x comma x times x, like this, good. And then what was your function, Bree?
I didn't get that part.
What'd you get, Cameron?
F of x equals x times x.
F of x equals x times x, perfect. Did anybody do anything different besides x times x? Is there a way that's a little bit simpler that I could write x times x?
X and then parentheses x.
X
that works, but that's still not, what'd you say?
X was second.
X squared.
Yeah.
Anybody think of that? Isn't that the same thing as x times x?
Yeah.
Okay, this works. This is not gonna get counted wrong if you put that on the test. But if you also did, or instead did x squared, or f of x equals x squared, that would be right too.
X plus.
It does look better, doesn't it? Nick, you got a question?
Yeah, please use the restroom.
We're almost done with notes. You're gonna have to wait. Yep. Okay, now we've got some real life situations. This is the very last part. We're almost done. Okay? And I'm actually gonna simplify this problem because I don't really love it, and we'll do some harder ones later on. But for today, I wanna make it a little more simple on us. Okay? So I just want it to be, you charge $18 to mow lawns.
Wow.
So you're making $18 per lawn.
That's not good. It's on X.
You need to raise your prices, you think? You think that's too cheap? Okay. Depends on the acreage.
Yeah.
That's true. Okay, but I just need you to write a rule to describe your profit as a function of the number of lawns mowed. Does it tell me what my X's or what my domains are? Or how many lawns I'm doing? No, so you can put whatever you want in for those X's. Tell me what the f of X's are, and then give me that pattern. So think about that one and go ahead and try it. Okay, one thing that might be a little bit confusing, this kind of is a typo. This should say p of x and x here. Don't throw another variable in there. I'm not doing systems right now. Okay, so x is a function. So it says the number of lawns mowed is x, okay? So it didn't tell me how many lawns. What did you guys put in this first column? Doesn't even really matter.
1, 2, 3, 4.
1, 2, 3, 4. Did anybody work harder than Chase and mow more lawns? Anybody do like 10, 20, 30, 40? Anything like that? Okay, 1, 2, 3, 4 works. So then, if I mow one lawn, what do I make? $18.
36.
2 lawns. 36, okay. 3 lawns. 54. And the last lawn, fourth lawn, 72. Okay. What was the pattern here?
Add 18.
So add 18 each time, right? Or just multiply x by 18. If I had to relate that to a function, so put that in an ordered pair, wouldn't it be x and then what would the y be?
I'm at 8x.
8x? Or you mean 18x?
Oh, yeah.
Yeah, 18x or x times 18. And then to write that in function notation.
What if you just do plus 18?
F of x equals 18x, good, or x times 18. Chase, the reason we can't do plus 18 is because 1 plus 18, is that 18?
What?
1 plus 18, is that 18? It's like to get from x to y here. To get from this x, yeah, so we can't do the plus 18. I get what you're saying though, because you see that this increases by 18 each time. However, what if I did this, Chase? What if I said that the next x value is 36? Is 72 plus 18 going to get me the right number?
For what?
No.
You'd have to.
For the next, price. But I put in a 36. You see that?
Yeah.
So the next number's not 5. So that's why it's better to have a rule like this versus just seeing what happens. Does that make sense? Okay. Cool. Very last problem of the day. Go ahead and try this one. Write a function for the following notation. It should say d of x traveled after x number of hours at a constant speed of 45 miles per hour. So for your x's, which we know are our hours, what did you put in that column?
1, 2, 3, 4.
1, 2, 3, 4. That works. Anybody do anything different? No? That's good. Keep it easy on yourself. What are the f of x's, or the outputs that you got for 1, 2, 3, and 4?
45.
90, 35, 88.
Good. The pattern is to do what?
Multiply x by 45.
Yep, multiply x by 45. So if you wrote that as a pattern and a coordinate point, what comma what? X comma 45x. Or x times 45 would work too. Function, last part. F of x equals 45x. Good. Questions on that? Okay, really quickly, before we do anything, I want you to go ahead and flip homework question, and we're going to do it together. Hold on. Okay, so the homework questions are worded just a little bit differently, okay? But they still mean to do the exact same thing. So I'm going to go ahead and I'm going to start with doing number 1. It says that P of t, which again is just f of x, they just changed the letters, I don't know why, equals 2t plus 4. It wants you to plug in 1. So when t equals 1, or when p of 1, what does p of t equal? So literally all you're doing is you're just plugging in. So p of 1 equals 2 times 1 plus 4. What's 2 times 1? 2 times 1 is 2, plus 4 is 6. So your answer is just 6.
That's it.
That's it. It's the same thing we did today. They're just throwing in different letters and different numbers, okay? We're going to do one more. So go ahead and flip to, let's do number 11 first. It says evaluate the following function f of x equals 2x plus 5 when x equals h plus 2. What do you think I'd do here? So if x is h plus 2, well, if I said x was 4, wouldn't you just plug in 4?
2.
So you're just going to plug in, so f of 2, or sorry, hold on. F of x equals 2 times h plus 2 plus 5.
How do we know H?
What?
How do we figure out H?
So you're not going to know what h is.
So it just means H.
Okay. Yep, you're just going to leave your answer. So 2 times h, 2h, 2 times 2, plus 5. Can I simplify that any further?
Yeah.
2h plus 9, that's your answer. Okay? And then 13 and 14 are the ones where you have to find the patterns. So go ahead and just put those in a table. Do 13 for you, but I'll go ahead and set up your table. So if you make an XY table, XY, your first 3 points are 2, 5, 4, 7, 9, 12. So find the pattern. Okay, they might not give you every coordinate point that you need. You might have to just use the pattern to figure out more. But you just need to tell me what does f of x equal? So that will be your answer. Okay? Any other questions?